So I'm really excited that you're here because there is nothing more cool than artificial intelligence right now. It is the shiny object above all other shiny objects, right? We used to have cybersecurity, and we used to have big data. We used to have all these great shiny objects, and the shiniest, the brilliant, the one that's shinier more than any right now, artificial intelligence. And Intel is determined to harness the power of this shiny object to, as you see in our commercials, not just talk about the future, but build it. In transforming government, though, artificial intelligence is taking on some very serious and real implications. And so I'm going to share with you a little bit about how Intel and Cloudera and its partners are actually transforming government today using artificial intelligence and what it means for us going forward. So it's ushering in a new world. Everything from undersea vehicles, robotic exoskeletons, this idea of deep space exploration, targeting and tracking systems, these are all elements in the government today, and especially in the DoD and military operations, where we see artificial intelligence taking a lead role. But it extends well beyond military operations. In fact, there is almost no agency that's not currently experimenting or investigating how artificial intelligence and data science can move their mission forward and help them achieve really great things that they weren't able to achieve before. So whether we're talking about health and life sciences, where we have phenotype and genotype analysis for genomics and precision medicine, or whether we're talking about high performance modeling and simulation via HPC, all these environments in government, they're taking full advantage of the thing that we call data science and artificial intelligence. So if you're part of a federal agency and you're really interested in understanding how to harness the power of these tools, you're in the right place. Because Intel and Cloudera, along with its partners, are spending a significant amount of time focusing on these issues. Now, the very first thing to do in this space is kind of think about all the things that are involved. If you're really looking at what's connected and smart, you're really looking at something that Intel's engaged in. And while Intel in the past, as you can see, started off with a lot of really great things in silicon architectures, and we continue to do that, Intel is pivoting to become a data company. And if you listen to our CEO, you'll see without question that Intel's focus in data extends well beyond just understanding what's running in silicon architecture. It really involves understanding how to harness the power of that data to create unique capabilities and experiences that our customers really care about. And in government, that means citizen services, that means cyber analytics, and lots of other things too. And we'll talk a little bit about those through this brief lightning round. It's really important, however, to deconflict what we mean when we say data science and artificial intelligence. And if you're like me, what you're seeing is a significant amount of confusion around what actually is being meant by all of these terms: core analytics, prescriptive, descriptive, diagnostic, and predictive, or machine learning and cognitive computing, or deep learning, convolutional neural networks, or general AI. And just like no hammer is the right tool for every solution, each one of these aspects of data science really requires a different set of tools and a different set of knowledge and a different set of capabilities. And it's important to understand these differences. Intel with Cloudera are putting their bets on all of these pieces. And if you were to take a look at the Intel portfolio, you'd see that there's pieces of our portfolio that cover all of these areas. And the primary reason is, just as I mentioned, you can't have a single tool to try and harness all of this power. So when you take a look at our portfolio, and I'm not going to go through each one of them, but you'll see at the bottom a set of silicon infrastructure, things like our Xeon, which is really accelerating and moving the training of algorithms forward at a performance rate much faster than competition, as well as Xeon Phi. You'll see a whole set of FPGA capabilities like Stratix 10 that's coming out and is available. and you'll see Optane in memory and other solutions in the silicon space. But what's notable about this slide is that that is just one of many different things that Intel has now in its portfolio for data science. And the vast majority of that has been focused in acquisition and mergers of different companies. Companies like Saffron, companies like Nirvana, focused on convolutional neural networks, deep learning, cognitive computing, and machine learning. These capabilities, along with open source frameworks that you're typically used to, like TensorFlow, Caffe, Python, Spark, and R, are helping to create a roadmap that allows the federal government to start anywhere in that road that they are in and mature their capabilities to create mission differentiators and accelerate their ability to actually create mission advances. So again, it starts with our silicon architectures. And so Xeon and Xeon Phi processors are ones that you're probably familiar with. But a recent acquisition of Nirvana includes an ASIC chip, an application-specific integrated circuit that is specifically tuned to deep learning and convolutional neural networks. This is why Intel is able to beat the competition, because while we have competitors that are on par with us on performance at the silicon architecture level, they aren't able to marry that architecture with software that's specifically tuned with workloads that are specifically optimized for artificial intelligence and data science solutions. Included in this new set of Intel infrastructure capabilities that are tuned to software would include the FPGA, the field programmable arrays, and they are optimized for performance as well. They provide the maximum flexibility for government agencies who are looking to have a clear understanding of how to move forward from one part of their infrastructure hardware, but then want to have application developers and provide them a unique field programmable capability that provides them maximum capability as their missions continue to evolve. One of these acquisitions we've been talking about, especially in the convolutional neural network and deep learning space, is Nirvana. How many people have actually heard of Nirvana? Yeah, so it was an Incutel investment in 2015, and last year an acquisition by Intel. And it is leading our artificial intelligence programming group. And its focus is on ensuring that we have not only the hardware and ASIC capability with its new layered silicon architectures, which accelerates deep learning in software, but the entire software stack that's married with that. So the Neon has the Neon open source tool has got a few pieces of secret sauce that have been added by Nirvana that allow it to take full advantage of not only the core capabilities in software, but now the optimized capabilities between that software and the hardware ASIC chip that came with the acquisition. So we're very excited about being able to apply new deep learning capabilities to government missions. And I'm going to share with you a couple of use cases where that's actually happening today. Another acquisition is Saffron. Now, you're probably familiar with Saffron. It is a widely used cognitive computing and machine learning tool. And unlike most cognitive computing and machine learning tools that have this concept of training, which takes a significant amount of time, and then inference, which is where we start using the training that we've done, it is a memory-based system, and it works exactly like the way your brain operates when you learn something. So here's how it works. As an example, how many times do you think it would take for you to know not to touch a very hot stove? How many times would you have to touch it before you realized maybe I shouldn't be doing that? 1. Okay, for me, maybe 2 at the most. But because I'm a little, slow on the get up. But for sure, it's not going to take me 100,000 times with a terabyte or a zettabyte of data to figure out that I shouldn't be touching that hot stove, like traditional machine learning training algorithms that are in the marketplace today. The memory-based representation model is married with a natural language processor as well as a detailed reasoning engine that allows us to get to the time of value much faster and compress this time associated with the training of algorithms to as soon as the data is ingested into the reasoning engine. That's a major differentiator. And we're really excited about the ability to use Saffron for things like drug interdiction, cyber intelligence, cyber analytics, and other things. So there's just a few more minutes left before I have to get off the stage. So I'm going to share with you a few of the case studies that we have been developing around these artificial intelligence and data science solutions. Cloudera, along with Intel, are using predictive clinical data and analysis to ensure they're able to provide healthcare professionals in the government and outside the government data that can identify patients that are at risk for future problems or sudden decline. And this is significant because Intel is working on the collaborative cancer cloud, as well as working on predictive and precision medicine from the previous administration's initiatives. And so we're marrying these capabilities to ensure that we have a real way of identifying future and predictive needs of patients. We want to have a real way to marry their needs in advance of them showing up at the doctor's office. We want to integrate IoT and wearable capabilities that allow us to actively look at what a patient is undergoing and provide remediation and interdiction quickly without having the person come to a healthcare provider. Our goal is to operationalize the concepts associated with the VA's digital health platform so that we ensure that they have the ability to help the hundreds of thousands of veterans that need accelerated health care. And we are working actively to ensure that we've harnessed the power of this as well as other technologies to make that go. That's exciting. It's exciting for us and exciting for our partners, and it's exciting for the government as well. The second one is around this idea of transforming cyber intelligence. Now, there are a lot of discussion around how we do predictive analytics on cyber intelligence and create huge data lakes. This one is really more focused on the processing of images and videos that allow us to do an accelerated analysis of facial recognition and object recognition. And along with our partners at Pixlogic, Cloudera, Intel, and Presidio, are working to create this new concept of aggregating all these technologies, focusing them on, again, IoT capabilities and large image processing and data environments, and allow the federal government to provide better, faster response using object and facial recognition. It is advancing the state of the art in our ability to create intelligent data science solutions, and it's having a material impact on the way national security and national homeland defense is being adjudicated. So we're extremely excited about it, and we hope you are too. There are some issues to consider while we're doing this, though. And if you've been following anything around data science and artificial intelligence, you know that these things are not something to be swept under the rug. The first thing is, of course, this idea that transformation value is not all in the shiny objects. You heard me talk about that earlier. But it really gets down to the nit and gritty of the design, development, and deployment of solutions in one of those multiple spaces we looked at on that slide that talked about the taxonomy. How are we actually going to harness the power of these technologies when we don't have enough data scientists? We don't have enough people who understand the open source languages. We don't have enough capability that allows us to do large ingest of data without some sort of material impact on security and privacy. So it's not all in the shiny object. And what that means then is that we need to rethink the entire digital strategy that we've been talking about in digital transformation and IT modernization in government. Just think about this. When you are able to talk to every device with a natural language processing capability, and every one of those are integrated in ways that allow them to share, aggregate, and analyze data at internet speed, today's digital strategy is not going to be enough. We're going to need to rethink that digital strategy to comprehend all of these nuances that this new artificial intelligence era provides us. Next is this idea of workforce and talent. Have anybody heard that artificial intelligence is going to have a negative impact on jobs? Well, that may be, But what's most likely is that we will have a positive influence on jobs. It's just there'll be different jobs. I spend a lot of my time thinking about the 20 jobs that don't exist today that will exist in the next 5 years. Can you think of one? One of those jobs is a neuromorphic engineer. What does a neuromorphic engineer do? This is a person who harnesses the power of neuromorphic computing, the ability to turn silicon architectures into a cognitive compute and storage mechanism, and engineer that for human augmentation. That's a job that doesn't exist today that will. And so while we have this discussion around workforce and talent from an artificial intelligence and data science perspective, keeping things in perspective is kind of important. And what we really ought to be thinking about is, what do we in government and those that support government, what do we need to do to support these new jobs? What kind of impact should we have on education and curriculum to ensure that when we need neuromorphic engineers, like at 2 o'clock, that they're there? And then this concept of data haves and have-nots, this is a serious problem. As we think about digital capabilities and artificial capabilities, or the outsourcing of some of the human cognition that we talk about in data science, it can create some significant caste arrangements between people who have large amounts of data and some people who are in data deserts. And so from a policy perspective, there's a need to think about in government how we will certainly provide some equalization, some equity around the use, development, and aggregation of large data. Certainly, people are not hesitant, in America at least, to contribute to this discussion about big data. The question is, what are they going to get back, and how are we going to protect them in doing so? Then lastly, ethics and transparency. DJ Patel, who was the first US chief data scientist, mentioned that ethics is a core responsibility of all data scientists, and that he was encouraging all folks in the data science space to spend some time in ethics, because the ability to outsource human cognition that has an inherent bias at internet speed can have a negative impact on people's ability to adopt any of the technologies that are the result of it. So things like autonomous vehicles and autonomous cars, or automated robots that are responsible for healthcare or retail, advanced manufacturing systems that are data science driven, need to have an ability to deal with this idea of human bias. And of course, the people who build these systems need to be more transparent about how they collect, aggregate, and analyze the data that's driving all of these great systems. So I hope what I've done is left you with a set of, as we say in Intel speak, ARs, action items that you must do, so that you can start thinking about how you're going to drive artificial intelligence in transforming your government agency or your organization. So thank you very much.